Hello, can you hear me?
Recording in progress.
Hello.
Hello, assalamu alaikum, sir.
Walaikum assalam. So, can you hear me?
Yes, sir.
Okay. I share my screen and start our today's session. Okay.
Uh,
Can you see my screen now?
yes, yeah.
Okay. So, I open my slide. Okay. And hi and welcome to the second day's advanced level 1 training session. And in this training session I am the course conductor. So basically today is our second day, but we also try to finish the first day's some session or topics. We also covered this in this here. Okay, so basically in this time I will discuss about the how to download the air quality parameters in time series data in CSV file format. Okay, then land surface temperature. Okay, how you can easily work with the land surface temperature or LST and observe the time series analysis, okay, using the Google Earth Engine platform. And then how to calculate the average, maximum and minimum NDVI or any other indices. Okay, so basically I also discuss all of the details in all of the three topics. But before I start this today's session, I also try to complete our first day's some topics which will not be covered for the yesterday. Okay, so I will first of all I will cover this, then move to our second days. Okay, so in this time first of all I also try to show you that the visualization DEM of hillshade map. Okay, so in this time I also discuss about this topic, how you can easily make the DEM or digital elevation model using the Google Earth Engine platform, and created the hillshade map as well as also create the salt map like this. Okay, so mainly in this time here I use the NASA SRTM digital elevation 30-meter data set. Okay, so I use this data set and create the map like this. Okay, hillshade map. So mainly I will do everything in Google Earth Engine platform for creating these tip images. Okay, then I just download these tip images and work with the ArcMap software. Okay, then create this map layout. Okay, so I also try to show you that how you can easily make the tip image. Okay, so first of all I simply open my code editor. Okay,
Can we try this on our study area?
yeah. So I already start your uploading your own study area, so it will be continue. So when I will already upload it, you can see it will be continue. So when it will be finished, then we can work with this your own study area, so that I think it okay. So it completed. So in this time I use this study area. I open a new code editor and just I refreshed my asset. Okay,
Yes.
so I simply find out your study area. So your study file name is that study area. So I find this from my asset tab. So
Study. Okay. Yes.
yeah, this
This study. Yes.
I think it's not, because check it. It's not.
No.
So study area.
Up. There you go. I think I see. Yes. Yeah.
This is study area. Okay, I
Yeah.
So we check it. So this is our study area. Okay, so I want
Yes.
to make the elevation map using this area, and I want to make the hillshade map and salt map only for this area. Okay, so first of all I just simply import my shape file in my code editor. Here you can see it will be imported as a default variable name as the table. Okay, if you want you can change it. It's totally depend on you. Okay,
Yes.
suppose I simply change it ROI, region of interest. This is my region of interest, and I want to need this region of interest for the elevation map. Okay, hillshade map or salt map. So in this time here I use the NASA SRTM dataset. So first of all, I just simply search here SRTM. Okay, I can get the SRTM dataset. You can see NASA SRTM digital elevation 30-meter resolution. I use this dataset. Okay, here you can get all of the information about this dataset. You can also see here the bands, and this dataset has only one band. This band name is the elevation. Okay, here you can get this minimum and maximum value is that it will be showing the pixel negative 10 meter. Okay, and up to 6,500 meters. Okay, we can easily observe using this band. Okay, so I just simply click on the import. You can see this dataset will be imported in our code editor. Okay, and here you can see this, it will be default variable name is the image. Okay, if you want you can change it. Suppose I simply give this name is the SRTM. Okay, so I imported my ROI, then I imported my digital elevation model dataset. Okay, so now I want to work with this. So first of all, suppose I want to show the visualization parameter. Suppose I simply take a variable, and then I simply take the variable name is the visualization parameter. Okay, then I simply make a dictionary. Okay, and in this dictionary I defined some suppose I want to show the result. It will be start from the mean, it will be start from the 0 meter. Okay, 0 meter up to max 300 meter. I want to show the result. Okay, above the sea level. Okay, from minimum 0 meter up to 300 meter. Okay, and I also use here the, suppose I want to simply use here the color. Suppose I simply use here the color plated and make a list, and in this list I defined which value or which elevation is 0 meter. Okay, which elevation is 0 meter or less than 0 meter, it will be showing as a blue color. I simply use here the blue color, blue. Okay, then this up to it will be showing the yellow color. I simply use here the yellow, and then up to I simply use here the red color. Okay, so I will define my visualization parameter. So now I want to show this result. I simply use here the map dot add layer function, and then I just simply call my image collection SRTM. Okay, I simply use here the SRTM, and then I simply call my visualization parameter is that this para. I simply copy and paste here. After this I simply use a layer name. Suppose I simply give the layer name is that elevation above sea level. Okay, I simply use this layer name, and I can get this result.
Level.
Okay, so then I simply click to the run. So now we can get this result for the whole world, and here I can get the elevation result. This visualization panel you can see from the 0 meter up to 300 meter. Okay, so here I can get all of the result in for the whole world. Okay, first of all I create this map for the whole world, then I can simply use the clip function for clipping your own study area. Okay, so you can get all of this result. So you can see I can get the elevation between this range. Okay, and now if you want to check the elevation, suppose I simply click on the map on the red portion. This is the high elevation. You can see 6,044. I simply click to here. You can see this is the low elevation only for the 7. Okay, so now I want to show here the hillshade map. Okay, so this is my elevation data. So now I want to show here the hillshade. Okay, using this data. So for this I simply take a variable and give this variable name is the hillshade. Okay, hillshade, and then I simply use this function. This function is the dot train dot hillshade, not this dot hillshade. Okay, so this is the spelling. So I simply use here my data set. You can see my input data set is that. I simply use my data set is the SRTM. Okay, this is my collection. You can see this is my collection. I give this variable name. So I simply remove this. So now I want to show this result. I simply use here the map dot add layer. Okay, and then I simply call my object. In this time I want to show this hillshade map. I simply call this and paste here. Then I also use here the range. Okay, hillshade range. In this time I simply want to show this height as that it will be start from the 150 meter. Then I simply use here the max up to 255. Okay, and then I simply define this is the hill shade. Okay, then I simply run this code. So now you can
The
see
is start from 150. Minimum is
yeah minimum and max. Yeah, I can simply use this. Okay, so now you can see it will be FER8 and we can easily understand some hill shade. Okay, so I also just decrease this value from here. So now you can easily understand from this hill shade. Okay, so you can see some parts of the hill will be available here. Okay, also hill available some here. Okay, so this is our hill shade map and it will be for the cover the whole world. Okay,
Yes.
okay, so now I also want to create it the solve map for the whole world. So I simply take the another variable. Suppose this variable name is the solve, and then I simply use here the ee.train dot solve. Okay, then I simply call my collection. So this my collection is that SRTM. Okay, I simply use here the SRTM. Okay, then I also show this result. I simply use here the map dot add layer, and then I simply use here the object is that solve. I simply use the solve, and then I use here the visualization parameter. Suppose in this time I use the solve, it will be start from the minimum 0 and use here the max 20. Okay, and then I also define this layer name is the solve. Okay, so now I want to simply run this code. So now you can get from here this solve map, as well as also you can get from here the elevation map. So here you can see there are the total 3 layer. Okay, first layer is the solve, second layer is the hill shade, and third layer is the elevation above sea level. Okay, so I simply, you can see this is our hill shade map. Okay, this is a solve map. Okay, so now you can get this result from here. Okay, and if you want to check this result from the inspector tab, simply click on the inspector, then simply click on the any portion of this map. So now you can easily get this result. Suppose you can see for this specific point, also you can see this is the longitude and latitude with their elevation 4,848. You can also see the hill shade, this is the 186. Also you can see solve 1.89 degree. Okay, so you can get all of this. Okay, from here. So now I want to use this data not only for the whole world. I want to use this data only for my own region. Okay, so my region I already imported in here. You can say I want to show this result only for this study area. Okay,
So one thing, sir, can you put here also the extract the results of aspects?
Yeah, we can also use this aspect. I think it will be available in here. So I simply search this aspect. You can see we can also observation. This is the same way. Just you can train dot aspect. Then you can just put the SRTM. Okay. Then you can simply show this result in here. Okay. We can also show the aspect, solve, train. Okay. Just follow this way. It will be okay. Okay. Just use this function. Okay,
So
Okay.
can we put it now, like with this results, with this analysis?
Okay, so just I simply take the another variable.
Yeah, yeah.
And then variable name is the aspect. Okay, then
Yes,
I simply use here the ee dot train
yes.
dot aspect, and then I simply put the our collection is the SRTM, this data set, and now I want to show this result. Suppose map dot add layer, and then I simply use here the aspect. This is my object, and what's the range you want to show here? Minimum range and maximum range.
Both minimum and maximum. In this northeast, east, southeast, southwest, west, northwest, like this.
Okay, so what's the mean and maximum pixel value you want to show in here? Okay.
How much?
Okay, I simply use this value, and it's depend on your what value you want to show in here. Okay, so I simply use this and simply use here the aspect. Okay, so then I simply click to the run. Now you can see here, we can see the total 4 layer. First layer is the aspect, then also you can see solve, then hill shade, then elevation. Okay. Okay, so now I want to show this result only for your own interest, area of interest. Okay, so your area of interest here I already